Black holes are one of the most mysterious and intriguing phenomena in the universe. These incredibly dense regions of space-time have captured the imagination of scientists and the public alike for decades. Despite their ominous reputation, black holes are an important subject of study for researchers in the field of astrophysics. In this essay, we will explore the latest research on black holes and delve into the many unanswered questions that still perplex scientists today. From the origins of black holes to their impact on the surrounding universe, we will delve into the many fascinating aspects of this mysterious force. What is a black hole? Black holes are points in space that are so dense they create deep gravity sinks. Beyond a certain region, not even light can escape the powerful tug of a black hole's gravity. And anything that ventures too close, be it a star, planet, or spacecraft, will be stretched and compressed like putty in a theoretical process aptly known as spaghettification. Types of black holes. There are 4 types of black holes: stellar, intermediate, supermassive, and miniature. The most commonly known way a black hole form is by stellar death. As stars reach the ends of their lives, most will inflate, lose mass, and then cool to form white dwarfs. But the largest of these fiery bodies, those at least 10 to 20 times as massive as our own sun, are destined to become either superdense neutron stars or so-called stellar mass black holes. There are 4 types of black holes: stellar, intermediate, supermassive, and miniature. The most commonly known way a black hole form is by stellar death. As stars reach the ends of their lives, most will inflate, lose mass, and then cool to form white dwarfs. But the largest of these fiery bodies, those at least 10 to 20 times as massive as our own sun, are destined to become either superdense neutron stars or so-called stellar mass black holes. Stellar black holes. When a star burns through the last of its fuel, the object may collapse or fall into itself. For smaller stars, those up to about 3 times the sun's mass, the new core will become a neutron star or a white dwarf. But when a larger star collapses, it continues to compress and creates a stellar black hole. Black holes formed by the collapse of individual stars are relatively small but incredibly dense. One of these objects packs more than 3 times the mass of the sun into the diameter of a city. This leads to a crazy amount of gravitational force pulling on objects around the object. Stellar black holes then consume the dust and gas from their surrounding galaxies, which keeps them growing in size. Supermassive black holes. Small black holes populate the universe, but their cousins, supermassive black holes, dominate. These enormous black holes are millions or even billions of times as massive as the sun, but are about the same size in diameter. Such black holes are thought to lie at the center of pretty much every galaxy, including the Milky Way. Scientists aren't certain how such large black holes spawn. Once these giants have formed, they gather mass from the dust and gas around them, material that is plentiful in the center of galaxies, allowing them to grow to even more enormous sizes. Supermassive black holes may be the result of hundreds or thousands of tiny black holes that merge. Large gas clouds could also be responsible, collapsing together and rapidly accreting mass. A third option is the collapse of a stellar cluster, a group of stars all falling together. Fourth, supermassive black holes could arise from large clusters of dark matter. This is a substance that we can observe through its gravitational effect on other objects. However, we don't know what dark matter is composed of because it does not emit light and cannot be directly observed. Intermediate black holes. Scientists once thought that black holes came in only small and large sizes, but research has revealed the possibility that mid-size or intermediate black holes, IMBH, could exist. Such bodies could form when stars in a cluster collide in a chain reaction. Several of these IMBHs forming in the same region could then eventually fall together in the center of a galaxy and create a supermassive black hole. Binary black holes, double trouble. In 2015, Astronomers using the Laser Interferometer Gravitational Wave Observatory detected gravitational waves from merging stellar black holes. We have further confirmation of the existence of stellar mass black holes that are larger than 20 solar masses. These are objects we didn't know existed before LIGO detected them. David Shoemaker, the spokesperson for the LIGO Scientific Collaboration, LSC, said in a statement opens in new tab. LIGO's observations also provide insights into the direction of black hole spins. As two black holes spiral around one another, they can spin in the same direction or the opposite direction. Einstein first predicted the existence of black holes in 1916 with his general theory of relativity. The term black hole was coined many years later in 1967 by American astronomer John Wheeler, after decades of black holes being known only as theoretical objects. The first black hole ever discovered was Cygnus X1, located within the Milky Way in the constellation of Cygnus, the Swan. How many black holes are there? How many black holes are there? According to the Space Telescope Science Institute opens in new tab, STSI, approximately 1 out of every 1,000 stars is massive enough to become a black hole. Since the Milky Way contains over 100 billion stars, our home galaxy must harbor some 100 million black holes. Though detecting black holes is a difficult task, and estimates from NASA opens in new tab suggest there could be as many as 10 million to a billion stellar black holes in the Milky Way. The closest black hole to Earth is dubbed the Unicorn and is situated approximately 1,500 light-years away. The nickname has a double meaning. Not only does the black hole candidate reside in the constellation Monoceros, the Unicorn, its incredibly low mass, about 3 times that of the Sun, makes it nearly one of a kind. Black hole images. In 2019, the Event Horizon Telescope, EHT, collaboration released the first image ever recorded of a black hole. The EHT saw the black hole in the center of galaxy M87, while the telescope was examining the event horizon, or the area past which nothing can escape from a black hole. The image maps the sudden loss of photons, particles of light. It also opens up a whole new area of research in black holes, now that astronomers know what a black hole looks like. What do black holes look like? Black holes have 3 layers: the outer and inner event horizon, and the singularity. The event horizon of a black hole is the boundary around the mouth of the black hole, past which light cannot escape. Once a particle crosses the event horizon, it cannot leave. Gravity is constant across the event horizon. Sometimes, as matter is drawn toward a black hole, it ricochets off the event horizon and is hurled outward, rather than being tugged into the maw. Bright jets of material traveling at near relativistic speeds are created. Although the black hole remains unseen, these powerful jets can be viewed from great distances. The EHT's image of a black hole in M87, released in 2019, was an extraordinary effort, requiring 2 years of research even after the images were taken. That's because the collaboration of telescopes, which stretches across many observatories worldwide, produces an astounding amount of data that is too large to transfer via the internet. Please be sure to subscribe to the channel, and don't forget to click on the bell icon to never miss any video from Spaceflight.